Hello learners, I am Dr. Nidhi Mathur, PhD in Public Administration and teaching at Institute of Management Technology, Center for Distance Learning, Ghaziabad. The subject expert is Dr. Neeti Mathur, teaching in National Law University, Jodhpur, Rajasthan. Previously, we discussed inventory control techniques used in operations research. Our topic of discussion for today is the queuing theory. A queue or a line is something in which we stand virtually or physically to avail the products or services. For example, when we go to a grocery store, we wait in queue to make the payment and check out at the cash counter. Thus, an ordered collection of items where the addition of new items happen at one end and removal of existing item occurs at the other end is called as a queue. The study of queues and random processes characterizing them is called queuing theory. Queuing theory focuses on creating mathematical sense out of real time formation function and congestion of waiting lines or queues. It includes two components at its core, the one requesting a service such as a customer or a job, and the server that delivers or completes the requested service. For example, a waiting line of customers in the banks seeking to withdraw or deposit money are the ones requesting a service, and the bank tellers are the servers completing the requests. Another example could be various tasks or jobs queuing up at the back end of your computer trying to get through an activity that is waiting to be served. Queuing theory is considered as a part of operations research, and it facilitates us with various models important in business and software applications to find out the waiting times or queue lengths. Queues are important in the situations when processing or serving multiple requests at the same time is not economically efficient, or when we do not have enough server space to process unlimited amount of computer jobs or tasks at one moment. Queuing theory is not only a first come first serve based waiting line model like a queue of customers in the bank. However, it includes more complex models based on various factors such as priorities, urgency of task, or maybe other relevant factors apart from these. For example, a group of job applicants waiting to be interviewed may be picked up one by one randomly. Types of queues. First in, first out. This is the most common and basic type of queuing, mostly relevant in banking, such as customers waiting in line for withdrawal or deposit of money, and commerce such as a shopping mart queue waiting in line for the billing and exit. Last in, first out. This is the contrary of the typical first in, first out system. In this type of queue, the first one to get served is the one waiting for the shortest time. Asset management or inventory management of the companies or businesses uses this type of queuing system. For example, the latest unit added to an inventory is the first to be recorded as sold. Similarly, the first one to be laid off in a company is the most recent employees. Priority. This is a special type of queue in which the elements such as a customer or a job is served according to the priority associated to it. The priority levels of these elements could be based on various factors such as task urgency, status, or any other relevant criteria. For example, the recent situation in the hospitals due to COVID pandemic requires priority queuing to allot beds and ICUs according to the severity of the patient getting admitted. Shortest job first. In this queuing system, the elements or people in line which requires the shortest service time is processed first. This type of algorithm is commonly used in CPU scheduling and processing tasks and jobs in software applications or an operating system. It improves process throughout by executing shorter jobs first or serve people in line which requires shorter service time first to have a short turnaround time, but waiting time shouldn't be a critical factor for the elements or people in the queue. Processor sharing. In this type of queuing system, the elements such as customers or jobs are all served simultaneously and the service capacity is evenly distributed amongst the elements waiting to be served. The people or items go through a single bottleneck in case of a single server, or there could be parallel servers serving the same line of people or items. There could be multiple servers, each with their own queue or line forming a tandem queue. Various discussed queuing type gives rise to certain activities such as barking, reneging and jockeying. When the waiting time seems to be too large to a customer and they decide not to wait, it is called barking. When a customer waiting for too long gets tired of the queue and leaves, it is called reneging. When a customer shifts between queues in a tandem queue system to manage the shortest waiting time possible, it's called jockeying. Types of services that use queuing systems. Queuing theory is a powerful system to manage waiting line situations and congestion control. There are countless and diversified services where it is applied in real time. To name a few: logistics, finance, emergency services, transportation, telecommunication, computing, project management, industrial management, Standard notion for queuing theory. To classify a queuing model, that queuing system corresponds to, we use a standard system with standard notations to make our life easier. It includes the following standard symbol: lambda, the mean arrival rate; m, the mean service rate; n, the number of people in the system; a, the arrival process probability distribution; s, the service process probability distribution; small n, the number of servers; d, the maximum number of customers allowed in the system at a given time, waiting or being served; e, the maximum number of customers total. Queuing theory process and real time examples. As we know that the delay in service increases when a system gets congested, queuing theory provides us all the essential tools required to analyze and understand the correlation between congestion and delay, and helps in designing an effective algorithm for congestion controls. There are various components of communication delays we need to understand before we proceed further. Delays are classified into the following categories. Processing delay. It is the delay between packet transmission receipt time and the time it is put in the transmission queue. It is also the delay between the time of packet reception in receipt queue and the time of its actual processing. It depends upon the speed of the CPU and its load in the system. Queuing delay. It comes into the picture post processing delays. It is the delay between the time of packet entry in transmit queue and the time of its actual transmissions. The load on communication link causes queuing delays. Transmission delay. It is the delay between transmission of first bit and the last bit of a packet, and it depends on the speed of communication link. Propagation delay. It is the delay between the transmission of the last bit of the packet and receiving of the last bit of packet at the reception. Physical characteristics of the communication link influences propagation delay. Retransmission delay. It is the delay caused due to a loss of a packet that needs to be retransmitted. It depends on the link error rate and retransmission protocols used. Little's theorem. To understand and analyze the queuing systems better, we need to know what Little's theorem has to state. According to Little's theorem, the following equation is used to determine the average number customers: n equal lambda t. Here n is the average number of customers, lambda is the average customer arrival rate, and t is the average service time for a customer. To understand this intuitively, let us consider an example of a shopping mart. If the customer arrival rate lambda doubles, but the service time t for customer remains the same, the average number of customers n doubles. Similarly, if the service time for customer doubles, but the arrival rate remains the same, still the average number of customers doubles. Little's theorem has helped us in understanding the basics of queuing system, and to further understand the characteristics of queuing system that influence its performance, we need to dig deeper in reference to our shopping mart example. and discuss various factors such as arrival pattern of the customers in the shopping mart. Are the customer arrivals more during a particular time window, or is the customer traffic more uniformly distributed? The amount of time customer spends while shopping in the mart, is it somewhere similar for each customer, or does the customer service time vary depending upon the intent of the customer and the shopping list length? The actual capacity of the shopping mart to process billings and exit procedure. The most important characteristics of a queuing system are being communicated through the mentioned factors. These characteristics are arrival process probability distribution A, service process probability distribution S, number of servers small n. Now, based on these characteristics, the queuing system can be classified by the following arrangement A/S/n. In this arrangement, A and S are the probability density of arrival process and service process respectively, and they can be of the following types: Markov M, exponential probability density, deterministic D, same value for all customers, general G, arbitrary probability distributions. With the above mentioned arrangements, the following instances of queuing systems can be defined: M/M/I. In this queuing system, the arrival time and service time are negative exponentially distributed based on the Poisson process. Poisson process is a model for a series of discrete events where the exact time of events is random, but average time between events is known. This queuing system is the simplest one to be analyzed, and it applies to the wide range of problems. It consists of only one server. It is best applicable for any system with large number of independent customers with different service time requirement that can be approximated or averaged as a Poisson process. M/D/n. In this queuing system, the arrival time is Poisson process and the service time distribution is deterministic. The system comprises of multiple servers and service time can be assumed as same for all customers. For example, ticket booking counters with multiple cashiers serving at the same time. G/G/n. This type of queuing system consists of arbitrary probability distribution for both arrival time and service time, and this system has n servers. This queuing system does not have any known analytical solution. Real time example: to understand the implementation of queuing theory for efficient management in operations of a business, we can consider a very common and easy to understand real time scenario of a regular Indian food restaurant. Suppose the restaurant offers 3 dishes: chicken curry, mutton curry and fish curry. Customer arrival gets overwhelmed during typical lunch and dinner time window and infrequent in the late afternoon. There are 3 cooks working in the kitchen during the rush hours, and each cook can prepare about 15 dishes per hour. Now, this makes the average customer wait time about 34 minutes based on the queuing model used, and that is a little bit high to keep the hungry customers happy and satisfied with the service. To reduce the average customer wait time, there is a need for preparing few dishes in advance. Using the queuing model, we can consider factors like quantity to be prepared on the basis of average customer turn up every day, most commonly and frequently ordered dishes, cost of losses related to spoiled food, etc. This can help in reducing the customer wait time to an average of say 20 minutes, and it makes the queue management easier. Eventually, the business operations get more efficient, that too keeping in mind the cost effectiveness and customer satisfaction. Similarly, putting queuing theory in practice can help improve business operations efficiency in almost every business sector such as manufacturing, wholesale, retail, travel, communication, etc. How does queuing theory impact your business? Many business owners assume that queuing theory is limited to minimizing the customer waiting time, as the theory focuses on analyzing it. However, in real sense, queuing theory is customizable for virtually every probability to be applied on almost every aspect of a business. We may use it to work out supply chain stock levels, material requirement, employee shift scheduling, etc. Queuing theory in multiple ways contributes significantly in improving business operations within a company. In other words, it can also be defined as management science that deals in finding most efficient ways to make use of limited resources. There are some defined steps that takes place in different phases of any business. Considering behind the scenes of a company to produce stock, ship and sell a product, there is a certain management involved, and as soon as an item completes one step in a process, it enters a queue of other items ready to move to the next step or phase, such as a ready product waiting in line for packaging, a motorbike on an assembly line waiting to be painted, etc. Similarly, considering the customer facing business process to complete multiple steps for purchasing a product, such as placing order and making payment on the first counter and picking up the delivery from the last counter, etc. In the entire business operations process, there is always a chance of falling into a bottleneck situation, making your operations less efficient, increasing cost and eventually affecting the customer base by not meeting up satisfaction levels. As we discussed earlier about the process of queuing theory, in real time it helps businesses by aiming to reduce above mentioned mishaps, considering the factors such as arrival process, queuing behavior, service time, waiting time and space, etc. These factors helps us in obtaining important information required to increase efficiency of operations, such as average wait time per customer or item average customers or items in a queue, actual utilization time of resources like employees and machines, maximum customers or items, handling capacity of the system, etc. Once the limitations are identified, improving the system and operations process becomes easier by planning effectively around those limitations. To understand the impact of queuing theory on a business, we need to discuss about certain areas that can benefit through it. such as product development. By calculating the total time spent on each phase in the production process, queuing theory can help in accurately forecasting the lead time on new product orders, which includes ordering of raw materials also. Similarly, it can be used to determine efficient use of floor space and equipment in case of manufacturing businesses. Supply chain management. Once we identify the bottlenecks in the shipping and warehousing through application of queuing theory, we can come up with solutions to improve and speed up the fulfillment time, lowering the associated costs for shipping and storage, reduce storage space, etc. Inventory management. By determining the customer demand through queuing theory, we can identify the amount of stock required to be kept in hand at any given time. The queuing types such as first in first out and last in first out are commonly used for inventory management depending upon the business model and the product. Customer service. By determining the finest balance of shift based employees, equipment such as cash registers and queuing methods such as multiple counters or lines using queuing theory, it makes it feasible to minimize the cost involved while keeping the customer happy. Now, let us conclude. The bottom line is that the queuing management is the key to smartly and efficiently improve the operations management in any sector or business that involves dealing with multiple items or people expecting to be served at a given point of time. Queuing theory holds a major importance in our system and society. When we talk about masses, we have to consider queue management to be in place. Waiting line is an unavoidable situation when dealing with multiple items and large customer bases, and thus queuing system is widely used in each area in the world. Having said that, looking at the historical significance of queuing theory, it has played a germane role in the queue congestion control of various sectors such as telecommunication, transportation, computer applications, etc. The scenarios we have discussed in this article makes it clear about the importance of queuing theory in both behind the scenes and customer facing process of any business and how it helps in cost cutting, waiting time reduction, maintaining a service discipline, channelizing arrival and service process, managing production, inventory, shipping costing, etc. Every aspect of any business and any organization dealing with people and products need a queue management to be efficient with their operations. Overall, we can say that queuing theory has helped us to study the movement of the people, objects or information through a line. It has helped in understanding the causes of congestion and helped in creating more efficient and cost-effective services and systems. It is often used as an operations management tool. It can address staffing, scheduling and customer service shortfalls. If there is no queue in business, it signifies overcapacity and waste of resources and hence having some queuing is acceptable and perfectly normal in any sort of business or organization. And queuing theory helps us in achieving the balance between efficient and affordable. So, that is all for today. Hope you have understood. We will meet in the next episode with a new topic. Till then, take care and goodbye.